was alone. I was all by myself for the first time in a long time. I was like, did I forget to put the link? Anyway, so you're here. Anybody else have questions from homework stuff or? Yes, actually I am. And remind me, I'm pretty sure that I made the quiz on Monday, right? Instead of Thursday. In fact, even if I didn't, just by asking the question, I basically did. So the quiz is on Monday. I actually have a practice quiz I just put together earlier today. I've just got to post it. And then we'll see when I create a video for it. But the quiz is on Monday. So there's some time for that. So you got some time to finish up that homework, especially, getting into section 8.3, which we still have to do like one or two more example problems to finish up for real. Anything else? Any other questions from homework? Anybody? Let me see. 18. I am over half. There we go. Here's somebody. Oh man. All right. I do need to. I've been really bad about reaching out to people, seeing what the hell's going on, because we do have 15, I think, more people in the class than is currently here. Anybody else? Questions, homework, anything? Oh, cool. All right. Maybe I can just get into chapter 9. Probably not. Okay. If there's no questions, I'm going to speak slowly because this is normally when I suddenly get a bunch of private chat questions. If there aren't any, we're going to get back into section 8.3. I don't see any. And I want to point out a major thing you definitely want to memorize related to this most recent stuff we've been doing. This is really important to know. The domain and range of these inverse trig functions. And we discussed the way we kind of created this was we did what we had to do to allow for inverse functions to exist. And thus, that's why these are the way they are done, right? So the domain is not a surprise for the inverse sine and cosine because that's just equal to the range of the sine and cosine. So that's what it is. These are what we had to kind of craft. We had to restrict the domain for the sine and cosine, so that becomes the range for the inverse sine and inverse cosine. Is everybody with me? Is my Wi-Fi doing okay? All right, I'm a little laggy. I feel like I'm playing a video game. All right. And tangent's got its own little weird thing. The tangent, to me, tangent surprisingly should be a little simpler because we didn't really have to sort of really restrict its domain. The one cycle of a tangent is what I have in my mind when I think about it. I don't normally think about an infinite number of tangents. So this one is just sort of that base cycle. And I know this is all pretty new to you guys, so you don't even like have it right there for yourselves. But this one normally is an easier one to remember. Okay, so I think the last thing we left undone in this section was to look at some problems like this. Let me just scroll down. Yeah, like a problem like this, right? So I'm just going to sit here for a minute. You guys try to do something with this, and I'll just sit here and make money, the big bucks. I just won't do anything. Yeah, lazy teacher. Sorry. I had some neighbors down the street. They're like, you teachers, never paying enough taxes, and you just sit around in your house. And that's me, evil.
Mode. Bluetooth connected.
All right, let's see. Oh, I got to switch this over to my other monitor. Sorry. Move you guys over there. Move this over here. Kabam. Now I can actually write some shit. Have anything weird over? No, good. All right. I mean, you know what to do here first. It's the same thing you've done first since the instant you first talked about parentheses in algebra. So you do the inside first. So that's its own little problem, right? That's like on the last quiz we did. So, I mean, you could do the reference angle. 13 pi over 6 is just past what?
2 pi. 2 pi.
2 pi. I like it because 2 pi is 12 pi over 6. So 13 pi over 6 is how much past? So this is not really to scale, but oh well. What else is new?
Pi over 6.
Pi over 6.
Pi over 6 past. I like it. Okay, cool. I like it. So then what's the cosine of that? It's closer. See, I didn't really draw it to scale, but that's 30. It's closer to the x-axis, so cosine should be bigger or smaller. Sorry?
3 over 2.
Yeah, root 3 over 2 should be the bigger option because it's closer to the x-axis. I like it. I should do a poll and see who has just memorized those and who's using the little things I've told you to use. But to be honest, all you got to do, if you can answer a damn question, I don't care what you did to get it there in your head, So now I can go back to this. So now I can rewrite this as inverse sine of rad 3 over 2. So this one's not crazy difficult, hopefully, right? All that's really asking is what angle gives me a sine of that, but the output for sine, inverse sine, who remembers this? What's the output? What's the range of inverse sine?
Negative pi over 2 to pi over 2.
I like it. So negative pi over 2 to pi over 2. Kick ass. I like it. And of course, for inverse cosine, that's from 0 to pi. That's the one that's actually nicer in some certain applications that we're going to see later. So when am I going to get a negative output for inverse sine? What quadrant would I have to be in to get a negative output for inverse sine? Or what would the input have to be? What kind of number would it have to be to get a negative answer?
Would it be closer to 3 and 4?
Can't say 3 because I want you guys to really, on this graph, 0, pi over 2, blah, blah, blah. Isn't this from here to here? Right? And so if the input is negative, that must mean it was actually something down here. If the inverse is, if the input is positive, that must mean it's something up here. Does that make sense? I mean, these are the kind of things you need to start to piece together. Okay, you know what the range is. What does that mean visually? How does knowing what it means visually help you out with problems like this? And some of you guys might never need to think about it that way. You can still do the problem. That's great. Just trying to give you every damn thing I can. So what is that going to be? I know it's going to be in quadrant 1 because the input's positive. So what angle in quadrant 1 gives me a rad 3 over 2 sine? Is it got to be closer to the y-axis or closer to the x-axis?
It's pi over 3. It's closer to the y-axis.
Yes. And is everybody with me on this? And again, if you are not making flashcards, you're just writing this shit down for yourself a million times like I would probably do. I can't even remember what I did the first time I learned this. I have no idea. I can't remember. Knowing me, I probably just sat there and wrote sine pi over 6 until I figured out the shortcut that I use now. I don't have these things memorized. I think I told you that. Not anymore. I think I did when the first time I learned this shit. So it's bigger Sine is bigger if it's closer to the y-axis, which means it's 60 degrees, which is pi over 3. All right. So there's that idea of the range of inverse sine helping me figure out what the output of this is going to be. So it gets a little more interesting down here on number 6. Can you guys see number 6? Hopefully it's not too far down there. Go ahead and try to do number 6. All right, I'm going to clear this so I can move that up here. Go away. Oh shit, what did I just do? Okay, there we go. So you start with what's inside. The reference angle for this is kind of nifty. Negative 11 pi over 4. So it's negative, so it's going this way, but it's just behind how many rotations?
3.
3. I like it. 3 pi. I like it. So it's so I go back pi, 2 pi, and then almost 3 pi. And of course, how short am I from doing a full 3 pi rotations? Or you know what I mean when I say that.
Pi over 4.
Pi over 4 away. I like it. So that's one skill to have, and that's not a terribly exciting or difficult skill, but you got to have that skill. And that sort of is part of the work you show me. Or if you don't show it to me, you're going to lose some points because it's part of the freaking work I got to see. So now what is this going to equal? I'm just going to focus on the inside here for a minute. So I'm going to put cosine inverse of, I don't know yet. Let me work on that. So sine of negative 11 pi over 4 equals, what can I do with this information now? It's in the third quadrant. So that, what does that tell me?
Sine is negative.
Negative. And it's the same as the sine of the reference angle. Become a thing. There we go. So what is sine of pi over 4?
Root 2 over 2.
Yeah, root 2 over 2. That's the nice one. That's where that's where cosine and sine are all agreeing with each other. Oh, that's such a nice thing. So now you got to remember, what the shit is the inverse cosine's range? Because I'm trying to get an output for this inverse cosine. So of course I got to know what the range is. What's the possible outputs this guy can have? And like we said earlier, that's 0 to pi, which really means it's the first and second quadrant. The input's negative, so what quadrant will this angle live in?
Second quadrant.
Second quadrant. That's the only way to make the cosine negative, is if it's in the second quadrant. And I already know what the reference angle is going to be. So what angle does that end up being? If I put the reference angle there, what angle is this? What's the answer? I don't know, Jeff. Why don't you just sketch that a few more times? Okay. What is that? Is everybody? You got to let me know the minute I leave you behind. I don't want to do that.
It's 3 pi over 4.
Yeah, 3 pi over 4. Maybe
Trying to do the math in my head.
I understand. I often get into trouble doing that myself. What is that, Jeff? 3 pi over h. That's fantastic. Oh, this pen drives me a little crazy. This pen's got a button right where I hold it. Anyway. We discussed last time dealing with this form, which is actually, I don't know if I'd say it's easier. I mean, once you see how to do these, you can actually attack those directly. This is where we can have a little more fun. What do I mean by that? I mean stuff like this right there. That's definitely more fun in my estimation. So let's do one of those real quick before, and then we'll get into chapter 9 a little bit. Let me see. I'm going to clear all this stuff. Bob, did we do? I think we did. I can't remember what parts of these we did. Did we do this one? I don't think so. Who remembers how to do this problem? Anybody? What is this inside set up for me?
Sides of a triangle.
Yes. So if I have this expression, this is really strange. I understand that, but I know that equals an angle. So this is really saying tangent of this angle is 7/4, and that is the very first thing we learned just about was just the basic idea of what the hell this means. This is going to be, if this is theta, this is a 90 degrees, my 7 is right there and my 4 is right there. So this expression, an inverse trig function, this inside is the ratio that would have been the output for the not inverse, for the original function. So that expression by itself sets up a triangle. And then the outside is just asking a question about that triangle. Okay, well, what about the sine ratio? What would that be? So, of course, what side do I still need? So this just becomes sine theta, where theta lives in this triangle. That's all that question becomes. So what do I need? I need this side. So it'll be 49 plus 16. Is that, Jeff? 65, right? Man. I'll be right. And so what's the answer then?
Seven rad 65 over 65.
I like it. So it'll be y over that. And if you, so it'll be 7 over rad 65. And then if you rationalize the bottom, it becomes that. So that's what that equals. I like it.
Can you
Just-
do another problem like you were doing earlier? I'm still kind of lost.
Oh, where the inverse is on the outside?
Yeah.
Okay. All right, we'll do that. I'm going to clear this. Go away. Let me see. What did we not do? We did both of those. All right, so we need more examples. I could just make one up. That should be exciting. Oh, we just do one out of the homework. Why not? Let me see. Number 11 sounds like one well, that's too easy. We want this stuff here. Here we go. Let's just do number 26. 26 is boring. Well, anyway, let's do 26 and then we'll do a freakier one. So I want you to realize the difference between 26 and 32, right, is that the inverse here is on the outside and the inverse here is on the inside. This, when the inverse is on the inside, this sets up the triangle that I can then figure out the cosine for that triangle, right? The ratio that relates to cosine. That problem is actually, in a way, it's a more straightforward, I guess. I don't know. This one is, the inside is just something I can do. I can just do it. So I do it. So what's the inverse cosine? What's the inside? What's the sine of pi over 3? Something you have to have memorized in some way. So again, what do you think? You think sine likes y. Go ahead.
Is it rad 3 over 2?
Yes, because sine likes y. Pi over 3 is 60. That is closer to the y-axis. So sine will be happy, meaning sine will be bigger. No idea if you like it like that. It's too bad. I don't know. You can make up your own way to do stuff. Since, and again, so now I got to think inverse cosine is basically quadrant 1 and quadrant 2. I can rule out quadrant 2 because it's positive in there. So what angle in quadrant 1 gives me a rad 3 over 2 cosine? So of course cosine's got to be, the only way to make it that big is if it was closer to the x-axis. So what angle does that?
Pi over 6.
Yes, I like it.
So it's basically like the opposite, kind of.
Well, this is, I'm really happy you said that. It's almost like you're living in my brain, because I just was thinking to say, if it's cosine, inverse cosine and sine, or inverse sine and cosine, you will see that relationship in some way. That's that complementary relationship, right? That's the one is 90 minus the other one. That relationship is showing up. It gets a little bit freakier if they're in different quadrants and stuff, but this was all in the first quadrant, so you can see that relationship perfectly. Once you start mixing tangent and stuff, then it kind of goes away a little bit, but that's a good thing to realize. Let's see, what else is down here? What about 31? Go ahead and do that. I'll sit here. Whoa. By the way, I keep forgetting, did I tell this class about did you guys fill out the evaluations for me? Did you see that up in Canvas? You should have gotten an email too or something. Everybody okay? And the dean is probably going to sit in on class at some point. She still hasn't got to me. And one of my colleagues is supposed to sit in on her class, but I sent him the link to YouTube and said, if you want to just look at all my recorded stuff, go ahead. But at some point, we might have some brand new person in here with us. Either way, we'll find out what happens. So where is negative 5 pi over 2? Where is that? Where do I end up?
Three pi over 2.
Yes, I actually end up there. I like it. Because I go back 4 pi over 2, which is back 2 pi, and then another pi over 2. So I end up at 3 pi over 2. So what is the sine of that then? So the sine of negative 5 pi over 2 equals negative, because it's down there, sine of 3 pi over 2. Get out of there, 3. Sorry. The reference angle would be pi over 2. Let's just get that out the way. So what is the sine of pi over 2? Or maybe you got memorized the sine of 3 pi over 2. It's just freaking down here, and it's on the y-axis. So what's it going to be?
-1.
-1. I love it. All right. So there's a lot of different ways to look at that. It's eventually -1. So now I can bring back the fact that this is the inverse tangent of what I just did. So tangent being 1, I know what that reference angle is. We're dealing with inverse tangent though. What is that range going to be for inverse tangent? I don't know if you guys remember.
Negative pi over 2 to pi over 2.
Yep, negative pi over 2 to pi over 2. I love it. And that's the same range as what else? What other inverse trig?
Sine.
Sine. And notice something really kind of beautiful. I don't know if you picked up on what I've said. This sine goes like tangent. When sine is big, tangent's big. When sine is small, tangent is small. So this is another connection between tangent and sine. It kind of makes sense because sine is on the top of tangent. So tangent sort of goes like sine. If that doesn't make any damn sense and you already know this fact some other way, great. Forget what I just said. And just a little preview. When we get into identities, we're going to find out that cosine is an asshole. So somehow that's going to make a lot of sense when we start looking at some of the identities. Cosine is an asshole. Okay, so we'll find out. That's a little teaser. So knowing the range, the output lives in the fourth and first quadrants. The input here is negative. So what quadrant must the answer live in?
4.
The fourth quadrant. I love it. So the range tells me what quadrants my answer angle can live in. The answer is negative. It must be the fourth quadrant because the first quadrant would be positive. So therefore, what is the answer? Now be careful. Let me see what you guys say.
Is it negative pi over 4?
Exactly. Yes. Don't go this way to it. You can't do that shit because this is where the answers have to live in. So it's you go this way, it's positive. You go this way, it's negative. So that's negative pi over 4. Kabam. I like it. Okay. Okay. Is that decent? So I don't know. I don't know if students necessarily would like these kind of problems better because you can actually do the inside and then you can work on the, and these problems are the ones where you draw a triangle and then work with it. I always loved these kind. And normally what I love is what students hate. So, you know, I don't know. Maybe some of you guys like what I like. I don't know. Okay. Okay. All right. Anything else, guys? Anything else you want to see again before we get into chapter 9? No. Okay. So let's do that. Yeah, I sort of feel like, oh, here's a chat. All right. Can you give me a little more specificity? Are you back in chapter 8? Is that where this question's coming from? It sounds like it. Oh, okay, okay. So a little review real quick. So let's say I had this function here. Sure, I like it. Ooh, that looks really yummy. How would I find the period? What part of this is related to the period?
Pi over 3.
The pi over 3x minus 4 pi.
This guy, the multiplier. I call him the multiplier because it's freaking multiplying x. So that's the multiplier. That's what we call k. Does it matter that you remember that letter? No. It's just what do you do with pi over 3?
Put it under 2 pi.
Put it under whatever the period is of the function. I like it. So it's cosine. So that period is 2 pi. If it was tangent or cotangent, it would have been pi. And you divide it by that. So here the pi's cancel. 2 divided by 3 is 2 times 3 is 6. Oh. Oh, okay, good. I like it. Yeah, it's that simple. So whatever that multiplier is, the period is affected by it oppositely. So it doesn't get affected by pi over 3. It gets affected by dividing by pi over 3. We know it's the opposite when it's inside with the variable. All right. Anything else before we... Oh, here's something else. Let's see. Yes. So what trig functions have a period of 2 pi? Oh.
Tangent, cotangent.
crap. That's the opposite. So,
Oh, that's
so
pi. That's pi. Never mind. That's pi. That's pi.
that's right. So sine,
Sine and cosine.
all right, that's a good start.
And then cos.
Yeah. And then cosecant and secant, because those are basically the same thing. I mean, really, right? Are you guys with me? So those are, this is just 1 over that. So whatever this guy's period is, this guy's period also is. So the only ones that have a period of pi are tangent and cotangent. I'm writing the whole name out because I don't do it a lot. It's just neat to do it. Cool. All right, I like it. Okay, anything else before I move on? I feel like I was about to do something else. Oh, well. That's too bad, Jeff. It's gone. So chapter 9 is where we get deeper into identities.
Sorry.
What's up? Is everybody all right?
So for literally the problems we're looking at, it says if it's not possible, explain why. Can you show like an example of it not being possible? Is that if it was not in one of the quadrants?
So let's see. So for example, can you see? So all of these are related to things we have to have memorized, right? So if I saw one that said 7 pi over 8, that would obviously be one I couldn't do without a calculator. You with me? All of these angles are ones we have to know. Does that make sense? No? What happened?
Yeah, it just says if it's not possible, explain why. So
Yeah, so what I'm saying is it wouldn't be possible to do it without a calculator. Not impossible to do, but impossible to do without a calculator.
Oh, okay.
Yeah.
Yeah, it asks for the exact value. So you'd have to know
find
what
the
they are.
exact value if possible. Yeah, if it's not possible to find an exact value, you have to explain why. So what could we not find the exact value for? It looks like I can find the exact value of all of these. I don't see any of these, unless I'm missing something. I don't see any of these that you could not do the exact value for, because here you set up the triangle and you can find the last side you need. And then these are all angles that are ones we have memorized. So I'm not sure what the point is. It's a little bit evil. Does that make sense to you guys? I mean, that's the only way to have something you couldn't do without a calculator is to have an angle that I don't know. Like 5 pi over 9. What's the sine of 5 pi over 9? I don't know either, right? I don't know what the hell it is. I could think about it and give you kind of an estimate, but there's no way in hell I could tell you the exact value. Anyway, so that's a little bit evil on the book's part. I don't know if I ever noticed they said this. It would have been nice to have that and then to have one of these actually impossible to do, which would have been like 5 pi over 9 or something, like I said. Is that all right? So that is kind of weird. I agree with you. Because I think every single one of these are doable without a calculator. Unless I'm missing something, which is also always a possibility. I don't see. No, I don't think I am. I think they're all doable. Yeah. Anything else, guys? Okay. So we're just going to do a little bit more. I'm going to give us a nice early night tonight. We're just going to do a little bit more. So appreciate that or hate that, whatever you want. So chapter 9 is going to get deeper into trig identities. And just to remind you guys of the identities we've already discovered, here are the Pythagorean identities. Do you guys remember these? Hopefully you do, because you got to memorize these bad boys. You must have these memorized. And if you remember what I said, if you memorize this first one, you can build the other two. It's up to you, right? Because remember, how did I build the other two off of the first one? Somebody remember? What would I do to this guy to build one of these two? Anybody remember? You're like, you just talk and talk, Jeff, man. I'm not even here, dude. No, come on. I divide this by sine squared. Does that sound familiar, anybody? So then I get 1 plus, what's cosine squared over sine squared? Cosine over sine is?
Cotangent?
Oh, cotangent. I like it. I'm getting a bunch of chats here. Yep. Oh, okay, no. All right. So that's going to be 1 plus cotangent squared equals 1 over sine is cosecant, and it's squared. And if I divide it by cosine squared instead, I would get this guy. Right? So you can either just memorize all 3 of these, or you can just memorize this first one and build these as you need them. It's up to you. But you're not allowed to have them written down for yourself. They must be in your head. Sorry, I'll stop. Let me clear those. So we already did a couple, I think there were a couple problems before that were verifying identities. Now it's going to be our entire life for a little bit. It's going to be verifying identities. So here's a nice little example. One of the most basic things you could do is break it down to cosine and sine. And that's basically that worked before. That's the way that the first couple that we did worked. But let me just do this crazy thing. Hiya! I want to look at number 29 real quick. I love 29. It's really simple, but it's different. Look at 29. Just think about it for a bit. What the shit would you do with that? So it doesn't really matter which side you work on, and it doesn't matter if you work with both sides. So you got this left-hand side, and you got this right-hand side, where it's normally a full thing. There you go. So I can work with this, and I can work with this, and my whole purpose is to try to make them become the same thing at the end, whatever the shit. So I can work completely with one side and make it become the other side, or the other way, or I could work on this side and I can work on this side at the same time. I don't know if you guys even understand what I'm saying. So does somebody have a vote for which side you want to work on, left-hand side or right-hand side? I love it. You're all like, if we don't vote, maybe we don't do this problem, we just leave. No, that's not how this is going to work. Nobody? You all like,
I'd say
Oh,
left.
I got a vote here. All right, I got 2 votes for left, and everybody else abstained. Okay. So let's work on the left side. So what can I do on the left side here? This is a cube. What the shit? Do we have any identities for freaking cubes in them? Nope.
Can you take out a cosine factor out?
Yes, totally. Sorry, I get a little excited. So factoring stuff still works. All that matters is that I have something that both terms have. So if I take a cosine out, what am I left with?
1 minus cosine squared.
1 minus cosine squared x.
I like it. So it's like in a little bit behind stereo. All right. So then what is this? What's 1 minus cosine squared? What's sine squared plus cosine squared? Sine squared plus cosine squared.
1, so that would
1.
equal sine squared.
Good. So 1 minus cosine squared must be sine squared. And isn't that what that side says? So that's an example of I picked a side, I'd worked with it all the way until it became the other side. So there I verified the identity. What will happen to you is you will pick a side, you will work with it, you will get stuck. You will be like, what the shit do I do with this? What you do is you stop working with the damn side and you work on the other side. And you see if maybe that goes all the way, or you can make them meet somewhere in the middle. Does that? So that's what I mean. This is something that we should do a better job as teachers kind of creating for you to happen before you get to pre-calculus. But this is where you really just have to play, and you have to accept that a part of doing the problem is kind of going down the wrong path or picking the wrong thing, or it's just a part of what that happens. It doesn't mean you're doing something wrong. It's just a part of what this is. Okay, maybe you guys, as you get to do these, I'm going to come back to what I just said, and I'm going to check in with you and see if you agree with me. Let me see. What else do we got here we can do right now? All right, I went a little bit deep into this. I don't know if you guys want to try these out. Hold on. Let's do one more, and then we'll call it a day. Let's see. Shit, I don't want to do that. I just want to do it straight up. Here we go. Let's just use some of these. I like it. Oh, let's do this last. This is what I was going to do earlier. Now it comes back to me. Forget about those. What is sine of negative x? How does that relate to sine of x? Are they equal to each other? And if you remember the symmetry, that's an easy question. But here's something really nice. Watch. If I have sine of some angle x, how does that relate to sine of the negative x? Are they equal to each other? Like sine of pi over 3 versus sine of negative pi over 3. Why are they definitely not equal to each other? Because sine here is, and sine
Positive.
here. Yeah.
Negative.
So they are exactly opposites of each other, because one would be sine of pi over 3 and the other one would be sine of negative pi over 3, which is negative sine of pi over 3, right? Because that's the reference angle. Are you guys semi with me? And of course, some of you guys might remember that sine is odd symmetry. Okay. So what do you think cosine of negative x is? Same idea here, right? So what's the cosine is the x piece. Does the x piece give a shit here? The x piece doesn't change. It's this. So cosine of negative x equals cosine x. So if I see a problem here that's got cosine of negative x, I can just rewrite that as cosine x. Kabam. Sine of negative x, I have to rewrite that as negative sine of x. So of course, what's cosecant of negative x? Why is that one? Why am I writing it where I'm writing it? Because cosecant and sine are basically the same in a way, right? One is one over the other, but that means that they react the same in this kind of situation. So cosecant of negative x is negative cosecant of x, because that's what happens to sine. So so secant of negative x, it'll do the same thing cosine does. It's just secant of x. Are you guys all right? What about tangent? What do you think about tangent and cotangent? No thoughts? No thoughts. Are you guys there? I know Brian's here. I heard him talk. I know Jason. I can see him. Doug's there. Sweet. Of course, you could still just all be in my head.
Tangent negative x is going to be negative tangent x, right?
Yes, because tangent is sine over cosine. And of course, if one piece of it changes sign and the other one doesn't, the whole thing changes sign. SIGN. Oh, God, man. I remember my first trig professor just always, SIGN, SIG. I'm like, oh, my God, dude, we understand. Sorry, a little flashbacks. And, of course, cotangent is going to be the same idea. All right, and I don't know if you guys remember when we talked about even and odd symmetries, I was doing the thing and that you guys really didn't like at all about how I look at even as positive and odd as negative. But if you don't like that, it's fine. It's just my own thing. That, I think, let's stop there. I want to have a nice early night for once. Help us all with the Zoom fatigue. If you don't like that, too damn bad. That's class is over. If you have any questions, let me know.
Thank you.
Thank you. Have a good day.
You too. Don't get used to it. Let me see. You too. All right. I'm not seeing any questions. I'm going to head out. See you guys.